Hi friends, this is Grishma from CSCA section from Math Shankara Institute of Technology. Today my design and analysis of algorithm topic is what is algorithm and types of algorithms in it. First of all, introduction to analysis of algorithm. A layman perceives that a computer performs anything and everything. It is very difficult to ensure that it is not a really that computer but the man behind the computer who does the whole thing. For examples, users just enter their queries and can get information as he or she desire. A common man rarely understands that a man-made procedure called search has done the entire task and the only support provided by the computer is the execution speed and organized storage information. Definition of algorithm. An algorithm is a set of rules for carrying out calculation either by hand or on a machine. An algorithm is a sequence of computational steps that transforms the input into the output. An algorithm is a sequence of operations performed on data that have been organized in data structure. A finite set of instructions that specify a sequence of operations to be carried out in order to solve a specific problem or class of problems is called an algorithm. An algorithm is an abstraction of a program to be executed on a physical machine or a model competition. An algorithm is defined as a set of instructions to perform a specific task within a finite number of steps. An algorithm is defined as a step-by-step procedure to perform a specific task within a finite number of steps. It can be defined as a sequence of definite and effective instructions while terminating with the production of correct output from the given input. Examples of algorithm. Let us assume can common example of ATM withdrawal systems to present to scenario of a person undergoes the following step. First one is swap the card, second one enter the pin, third one is put the amount, fourth one is withdraw the amount, fifth one is check the balance, and sixth one is cancel or clear. If we go through these above 6 steps without considering the statement of the problem, we should assume that this is the algorithm for clearing the toilet. As of several ambiguous exits there while comprehension every step. The step 1 may imply toothbrush, paintbrush, toilet brush, etc. such as ambiguous does not instruction an algorithm step. Thus every step post would be made unambiguous step is called a definite instruction. Even if the step 2 is rewritten as apply the toothpaste to eliminate the ambiguous at the conflicts such as where to apply the toothpaste and where the source of the toothpaste is need to be resolved. Therefore, the act of the applying the toothpaste is not the mentioned. Although ambiguous, such as the unrealized steps can be included as algorithmic instructions as they are not effective. The definite and effectiveness of an instruction implies the successful termination of that instruction. Hence, the above two may not be sufficient to guarantee the termination of the algorithm. Therefore, while designing an algorithm, care should be taken to provide a proper termination for algorithm. Characteristics of an algorithm. Every algorithm should have the following 5 characteristic features: input, output, fitnessness, definitionness, effectiveness, precision, determination, correctness, and generality. Input. First one, an algorithm may have one or more inputs. The inputs are taken from a specified sets of subset, and input pattern may be text, images, or any type of files. Second one is output. An algorithm may have one or more outputs. Output is basically a quantity which has a specified reasons with the input. Third one is finiteness. An algorithm should terminate after a countable number of steps. In some cases, the repetition of steps may be larger number. If a processor is able to resolve infinite number of execution of steps, then it is referred to be a computational method. Definiteness. Each step of an algorithm must be precisely defined. The action to be carried out must be unambiguously specified for each case. Due to the lack of understandability, one may think that the step might be lacking definiteness. Therefore, in such cases, mathematical expressions are written so that it resembles the instruction of any computer language. Effectiveness. An algorithm is generally expected to effective means the steps should be sufficiently basic so that it is maybe possible for AI to resolve them. Precision. The steps are precisely stated. Determination. The intermediate results of each step of execution are unique and are determined only by input and output the preceding steps. So correctness. Output processed by the algorithm should correct. Generality. Algorithm applies to set of standard inputs. What is the computer algorithm? A set of steps to accomplish or complete a task that is described preciously and enough that a computer can run it. Described preciously, very difficult for a machine to know how much water, milk to be added, etc. in the about tea making algorithm. These algorithms run on computers. Computational devices, for example GPS in our smartphones, Google Hangouts. GPS uses shortest path algorithm. Online shopping uses cryptography, which uses RSA algorithm. Characteristics of an algorithm: must take an input, must give some output, yes or no value, etc. Definiteness: each instruction is clear and unambiguous. Finiteness: algorithm terminates after a finite number of steps. Effectiveness: every instruction must be basis like a simple instruction. Expectation from an algorithm. Correctness: correct algorithms must be produce correct result. Produce an incorrect answer even if it is false to give correct results all the time. Still, there is a control on how often it gives wrong result. For example, Rabin-Miller primality test used an RSA algorithm. It does not give the correct answer all the time. 1 out of 250 times it gives incorrect result. Approximation algorithm: exact solution is not found, but near optimal solution can be found out applied to the optimization problem. Less resource uses: algorithm should use useless resource, time and space. Resource uses: here the time is considered to be the primary message of the efficiency. We also connected with how much the respective algorithm involves the computer memory, but mostly time is the resource that is deals with, and the actual running time depends on a variety of backgrounds like the speed of a computer, the language which is the algorithm is implemented, the compiler, interpreter, skill of the programming, etc. So the mainly the resource uses can be divided into one: memory space into time taken by the algorithm, performance measurement or approximation analysis, implementing the algorithm in a machine and then calculating the time taken by the system execute the program successfully, performance evaluation or appropriate analysis before implementing the algorithm in a system. This is done. Thank you.